In the last couple of weeks, I have talked about an optimization in GameMaker that I don't think is very interesting, and I've also talked about an optimization in GameMaker that actually makes your game slower instead of faster, so it's not really an optimization. And I think we're going to round that off today by talking about an optimization that I think is very interesting, but the number of times when you can actually use it is actually extremely rare. So I'd like to put a big, huge disclaimer on this video that this is, by pretty much every account, a micro-optimization. What I'm going to talk about today can and will make your game slower instead of faster if you apply it inappropriately. I'm going to be getting to that later in the video. And on the occasion that what we do today actually can work, it's not actually going to save that much time. The optimization that I'm going to talk about in this video also comes with some trade-offs that it's important to acknowledge and respect, because trying to work around them or outsmart them in some way can and will make your game slower as well. All in all, this is the sort of thing that you should only do if you have exhausted literally every other possible option for making your game faster. So at this point, it should probably also go without saying that what we're going to cover here is some pretty advanced stuff. This is not something you should probably bother yourself with if you're not already intimately familiar with how GameMaker works internally and like what individual VM instructions are doing and the things that make individual lines of code fast or slow. We are going to be saying a lot of words like pushing values onto the call stack today. So if you're not into that, then I do have a whole bunch of other videos on optimizing games in GameMaker. For what it's worth, all those other videos are just going to be way more useful in general than this one is going to be as well. Anyway, we're going to start off with everybody's favorite thing, and that is going to be some historical context. So right now, GameMaker's built-in scripting language GML looks pretty JavaScripty. It's fairly nice. You can do things like define functions. And to use my favorite example every time I demo a basic function, we're going to have it return something like a plus b. And you can, show a message, the result of some function. We'll just give it a couple of numbers. I don't think there's going to be any surprises as to what this produces. GameMaker also allows you to, in the modern day, define anonymous functions, and these are functions which will, for example, live in variables, something like var f equals function a b, and we're going to return a times b or something like that. And you can also go and call this anonymous function that lives in a variable basically the same way. Again, probably not going to be any surprises unless you were listening to me saying a times b and didn't notice the part where I typed a minus b. So, in the long arm of history, the way that GameMaker looks right now is actually pretty new. For the longest time, it wasn't until, say, 2020 or so that the way that GML looks right now really came into being. Before that, we had all kinds of crazy nonsense, like every script file that you defined necessarily was one and exactly one function, and you had to use this really annoying thing called the argument array or the argument keywords if you wanted to pass arguments to a script. It was a whole thing. Don't know how we survived. Long story. Not today. Anyway, the important part of this for our understanding of the rest of this video is that if you had something like this, you couldn't simply say like a variable equals some function, and this variable would now contain a reference to that function and be able to just call it. So now in modern GameMaker, this is fine. So this will call that function by reference like this. But prior to GameMaker in 2020, this was not the case. This would have caused a compile error because you couldn't just like toss scripts and or functions around like that. What you had to do instead was use a function called script execute as sort of a proxy for polymorphic behavior. And using the script execute function, and I'm just going to get rid of this. Using the script execute function, you could take a reference to a function like this, and you could pass the arguments to it sort of indirectly, and what would happen would be that the script execute function would take a function and execute it with the arguments. It would take whatever function reference was stored in the variable and execute it with those arguments. And this still works in modern GameMaker. You'll pretty much never see it now, except for like compatibility with really old code. But back in the day, it was unfortunately not uncommon to use this as a way to jam polymorphic behavior into an engine that really didn't want it. You also could, of course, take the sum function like this, the named function like this, or in the old days a script, and call it directly, and that would also, you know, work. By the way, as a fun aside, me and Tabular Elf went on a bit of a treasure hunt to try and figure out exactly which version of GameMaker this was added to, and it appears to be somewhere around GameMaker 6, which I think was like 2005. We couldn't figure it out exactly because, like, some of the really old versions of GameMaker don't work on modern Windows, and I wasn't about to, like, bust out the old Windows 7 crap top to just for the sake of this. Anyway, in a post-GameMaker 2.3 world, the script execute function is pretty much dead and buried. However, there is another function which is related to it, which is script execute extended, and this function is actually really interesting. So what this function does is, it allows you to take a reference to a function, and I should also say that this can be a function that you defined or a function that, like a runtime function, one of the ones that are built into GameMaker. But instead of asking you to list out the arguments just like in order as like extra parameters to the script execute function, what it will instead do is it will accept the arguments to the function as an array. And I guess I'll go back to show message of this. And if I run this, it's going to work, and it's going to run this function, run this this up here with the arguments 1 and 2, the values that are inside this array. And this looks like a really minor and not very important difference, but this is actually really interesting because there are a couple of functions in GameMaker, such as mean, min, max, median. They tend to start with the letter M. They tend to be math functions. There's a couple of functions in GameMaker which can take as many arguments as you want to give them. And what this means is that you have the classic way of, let's define an array. Let's make it really big. Array create like 50,000 or so. I'm going to fill it with random numbers. I'm going to use the array create extended function for this. And we're just going to populate it with random numbers between 0 and 100,000. Let's say that you want to actually take the find the minimum of this array. So we can do it the classic way by saying var smallest equals infinity. And we can loop over the array for var I equals 0, I is less than array length, I plus plus. And you can do what your first instinct to find the smallest value in a list probably is, and that's going to be something like if smallest is less than array index I, smallest equals array index I. If you'd like to go further, you can do it maybe your second instinct is, which is to say smallest equals min of smallest and array index I. We can make this a little bit faster by saving that one array access. If you're really anal about for loops, and I can always tell who leaves comments on these videos without watching them, because I always get comments about this, even though I always acknowledge it. Var I equals 0, repeat array length array, and now we need a loop counter. By the way, I keep seeing this come up. Putting I++ in line in the array access makes no difference whatsoever. It's the same number of VM instructions. It's the same. People keep saying this because back in like 1971, you could save like a single call stack push by embedding the postfix increment operator instead of doing it as a separate statement. But like compilers in 2026 are smart enough to be able to figure out what you're doing and optimize either way. The GameMaker VM, it makes no difference. It's the same number of VM instructions. Anyway, this is going to give us the smallest value in this array. If we'd like to see what that is, show message smallest. And also, if we'd like to figure out how long this took, we can use the old get timer trick. T0 equals get timer. Var T1 equals get timer. This will detect this will return the system time between when this code started and when it ended in microseconds. And then you could just show the elapsed time. Show message. I'll do T1 minus T0 divided by 1,000 because I'm more interested in milliseconds than microseconds because it's easier to read. The smallest value in this list is 0.85, and that took 4 milliseconds to run. Alright, so where does script execute extended come into this? Remember how I said that there are functions like min and max and whatever that will take as many arguments as you want to give them? They're variadic in that way. So what if we could call the min function on just like every value in this array at once. So like array index 0, array index 1, dot dot dot, array index 49,999, like this. What kind of a difference would that make? So if we took the script execute extended function, and if we said var smallest equals script execute extended, and the function that we ran is going to be the min function, and the array that we're going to run it on, the array of values, is just going to be that array. How long do you think this is going to take? So I'm going to run this, and we're going to see that it produces the same answer, because it's doing basically the same thing internally. But, is that right? Is there something wrong with my test? It should have been like 1/10 of that. Alright, that's better. 0.35. I feel like the first result that we saw there was the result of like GameMaker freezing in the background or something. 0.36. If I run this over and over again, we could see that it's going to produce a result that is about an order of magnitude smaller than what you would have seen by doing it yourself. So that's interesting. We can also do this with other functions like array, like the max of an array, the mean of an array if you want to get an average. See how long this takes. The average is about 50,000, which makes sense because it's going to be half of the max value. It's going to take about the same amount of time. Alright. Median might be a little bit different because it's not just going to iterate over the array once. It has to actually, like, intelligently figure out, oh, we didn't like that. Does the GameMaker median function internally have some kind of recursion going on? That's weird.
Hey.
I'll have to check the source for that. Anyway, median probably isn't a function that you would use on that because you could also just array sort and then pick the value in the middle. But that is one thing that you can do with the script execute extended function. Again, I said at the beginning of the video, this is probably not something you're going to do very often. Just think about in all the time you've spent making games, how many times you need to find the smallest value in an array of 50,000. It's probably not that many. Maybe the mean or the average is something that you might do a little bit more often, but other than that, this is a very, very situational sort of thing. So there's another use for the script execute extended function which I'd like to try out, and that is going to be in drawing functions. So I've gone and more or less copied at least parts of the like the obj_smiley that I was using in the anti-optimization video last week. So we have a bunch of these smiley faces, and they're going to be initialized with some values. So a random rotation, a random image blend, a random image x scale, y scale, and I've also got the spawner object, which is going to go and draw like 30,000 of them in a room. I think I can actually, you know what, let's not include that debug overlay. I'm going to be looking at the profiler anyway, which just shows more information. So 30,000 of those. We don't currently have a draw event, and I'm going to add a draw event now. And I think we're going to have it draw sprite extended. And what? Draw sprite x tabs. Interesting. Draw sprite extended. This is a function which is going to take a couple of arguments. So we have sprite index, of course. We have image index. We have x, y, our position on the screen, our scale, image x scale, and image y scale. We have a rotation, image angle. We have a color, image blend. And lastly, we have an alpha, transparency, image alpha. GameMaker does have a lot of built-in variables pertaining to drawing sprites. If I run this in debug mode and if I look at the profiler, we can see that it looks, we've got a bunch of multicolored faces like this, and they're rotated in random ways. And if I were to go and start profiling, we could take a look at how long this takes. So, all told, this is taking about 7.5 milliseconds, and if I expand this, we can see that the draw sprite extended function itself is taking about 3.5 milliseconds, so a little less than half the total time of the draw event here. And the time that's unaccounted for, the time that isn't reported in the profiler, that is going to be the time that is actually taken up by actually resolving these variables, pushing them onto the call stack, having the draw sprite extended function actually like interpret them. So that's interesting, to be sure. Again, there's 30,000 of these things per smiley face. That's not a lot. So if I take 7.5 milliseconds divided by 30,000, that is about 250 nanoseconds per smiley. It's not a lot, but if you have 30,000 of them, then, well, it does add up a little bit. So, just to get this out of the way, if you're doing this and your game is running slowly, the first thing you should consider is not having 30,000 smiley faces like this, 30,000 objects active in the room all being drawn at the same time. That is a surprisingly good optimization, and it is surprisingly one that people don't seem to like doing most of the time. But anyway, in this example here, we've got about 4 milliseconds per frame that's just resolving these variables and pushing them onto the call stack. So what if, since none of these are actually changing from frame to frame, what if we just took these, put them in an array in the create event, for example, and let's call it draw args equals an array of these values. Actually, let me call it draw sprite extended args, because I will be showing this with other draw functions later. And what if instead of actually calling this explicitly, we called it somewhat indirectly with the script execute extended function, and we can give it the draw sprite extended function that we want to call. The arguments that we can give it are going to be the draw sprite extended args. And if I run this now, and if I head back to the profiler, we can see that we've gone down from about 7.5 milliseconds per frame to a little less than 7. So that's okay. That's about maybe an 8% savings, which is not going to set the world on fire, but it's also not nothing. We can see that the script execute extended function itself is taking a little bit longer than just draw sprite extended was. The difference being that we've got to do an additional layer of indirection where we actually call the function, and we, in the GameMaker runtime, resolve the arguments instead of doing it in GML. So that's going to add a little bit of time, but not a tremendous amount. We've still got a little bit of time unaccounted for, which, honestly, I don't know where all of it comes from. I can't imagine that simply, pushing 2 arguments onto the stack is going to be that costly versus pushing 9. There is some other stuff that GameMaker, does by default in the background, which is probably where that comes from. So, okay, you might logically think that the amount of time saved from doing this will scale with the number of function arguments that you might evaluate yourself in GML. So, draw sprite extended is not the function with the most arguments in GameMaker. There are a few others. Draw sprite general is the most generic sprite drawing function in GameMaker. This will take not 9, but 16 arguments. So we've got the usual things like sprite, index, and image index, but we've also got coordinates on the sprite which we want to draw, because draw sprite general allows you to draw only part of a sprite. So if you want to draw the entire sprite, you might say the left and top coordinates for more to draw are going to be 0, 0. The width and the height, if you want to draw the entire sprite, might be sprite get width and sprite get height, like that. We also have, as usual, the X, the Y, image, X scale, image, Y scale, rotation, image, angle. We have blending color. We have 4 different blending colors that we might supply. And that's because draw sprite general takes different colors for each of the corners of the sprite. And, of course, image alpha for transparency. So that's 16 arguments. If I go and run this in the profiler, we can see that this is going to look sort of the same. Image rotation is going to be a little bit messed up because the anchor point isn't used in draw sprite general. But if I go back to the profiler and have a look at how this is performing, we can see that we are taking 10.9, about 11, let's call it 11 milliseconds per frame to draw all this, and we can see the breakdown. Sprite get height is going to take up a little bit of time. Sprite get width, draw sprite general is going to take up a little bit of time. And again, pretty much all the time unaccounted for is going to be the actual resolution of these arguments in this function like this. And if we were to go and, instead of calling this directly, we were to pack these into an array. So draw sprite general args can be an array which contains these 16 values. We can go and take this. We can go call draw sprite general and draw sprite general, give it the draw sprite general arguments, and we can run this now, and we can see how long this is going to take. So if I run this in the profiler, if I go and profile the game, we have gone up slightly from the 4.1 milliseconds that it took script execute extended to execute on the the other draw function to 5.1, but the amount of actual time that it's taken to do everything else has gone down from 11-ish to about 8-ish. And that is, what, 30% or so, maybe 35% if you're feeling generous. And that's, again, not going to set the world on fire unless you are doing this 30,000 times every frame. But 35% is definitely an increase that's worth considering. All right. So now that I've made this sound very exciting, 30% improvement in speed and whatnot, let's talk about all the reasons you might not want to do this. So this only really works if you're calling a function which has a lot of arguments. Draw sprite general takes 16 arguments, and if the arguments don't change every frame. So if I do something like, let's say in the, let's give this a step event and say image angle plus equals like 5 or something like that. So if I were to have these objects rotate on the spot, if I were to invoke the draw code manually, we would see the object's angle updating as they... Okay, that's pretty fast. The object image angle will be updating every frame as the rotation value changes. This is going to wreak havoc on the YouTube video compression, isn't it? I noticed that in the last video when I did this, that the scenes where the things were moving around was really very... made the compression look like a snowstorm. Anyway, so if these values change every frame, then just like calling this function like a normal person will not give you any trouble. But if these, if we do update the... Oh, I need to comment it back in. If we do update the image angle every frame, and if we have cached these values in the create event, then now if I run the game, they're going to be frozen in time. They're going to be using the image angle that they started with. Any updates to their position, angle, scale, anything else like that that might happen after that are not going to be updated. If you would like to update one of these values, you will have to go and, let's see, image angle is going to be argument 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, index 10 in this array. So we can say draw sprite general args index 10 equals image angle. And now if I run this, this one change, we are going to see that, like, if I look at the profiler, we already have a very significant... Actually, it probably would have been better if I showed this after I added the step event, but before I added the update to draw sprite general args. So let me do this again. So, for a more fair comparison, we are updating our rotation, but we're not updating the cached value, and our step event is taking little less than 2 milliseconds per frame, and our draw event is taking the same. If I go and go back here and comment this back in, we are going to see that just doing this, just updating this one value is going to increase the cost of our step event by almost an entire millisecond. And our draw event is still pretty much the same. This says updating this one value has wiped out a significant portion of the savings of what we saved by caching the draw arguments. Anyway, I'm not about to sit here and do the bookkeeping to figure out exactly how much you can get away with before the amount of time wasted eclipses the amount of time saved. The results will differ between VM and YYC, by the way. Feel free to test that and see how much of a difference that makes as well. But ultimately, this is really only worth doing if you can get away with doing as little as possible. Like, the whole point of this optimization is to just let GameMaker handle things, and trying to work around it by being clever about updating the values in the array is kind of antithetical to the point of the whole thing. Other reasons which this might end up being slower than if you just left it alone. So, functions that don't have a lot of arguments in them. So let's go back to the basics and just use draw sprite. And this, of course, has 4 arguments. We have sprite, index, image, index, index. We have x and we have y, like this. So how much time is this going to take us in every step of the game, every frame of the game? And we don't have rotation, scale, or blending because draw sprite function doesn't support those things. If I run the profiler, this is going to take about 5.9 milliseconds per frame to do all this, so it's slightly less. We're not doing quite as much as we were before. The draw sprite function itself is going to take slightly less time. If I were to go and close out of that, and if I were to go and cache these values, we can call them draw sprite args equals that. We can go and comment this out, we can call the regular draw sprite function in place of that one, and we can use the regular draw sprite args in place of the other ones. That was not debug mode. I wanted debug mode. And let's go back to the profiler and start profiling. And we can see that the amount of time that it takes to render a frame has now increased from a little less than 6 milliseconds per frame to a little bit more than 7. So that is a loss, maybe about 20% or so. And the reason for this is that the extra indirection that we have to expend by doing this is actually greater than the amount of time that it took to push 4 values onto the call stack. So definitely don't do this all the time. You should definitely, this goes for pretty much any optimization, but especially this one, if you do something like this with the drawSprite general function, definitely test it to make sure that you're actually saving time and you're not wasting time. And honestly, I kind of feel like drawSprite general is the only function in GameMaker that's really worth doing this on in the first place, because most of the time, if you call a function multiple times, like every step or something like that, you could also just like save the result of that function, and you could reference the result of that function if the input arguments to it don't change. Things like math functions, obviously, matrix functions. Like, if you matrix build a bunch of times in succession and the arguments that go into the matrix build function don't change, the position, rotation, or scale, then there's really no reason to just calculate it over and over again, as opposed to saving the matrix and reusing it later. That's also the case for like most functions. Other functions that have a lot of arguments are things like MP, grid. These actually don't have as many as I thought they did. I think MP grid path has the most functions that go into it. This still isn't as many as like drawSprite extended. Calling the MP grid path function multiple times with the same arguments won't necessarily produce the same result every time, because it depends on like the state of the rest of the content of the grid. But you also probably wouldn't call this function with the same arguments every time. Like, agents move around in the game world. They might navigate to different goals. It's probably not worth using something like this with script execute extended either. And the only function that I can really think that you would really want to regularly do this with is something like drawSprite extended or drawSprite general. And that's because, like, if you call it with the same arguments every time, there's a purpose for doing that, which is that it is for drawing. It's not for computing and returning a result. And also, kind of by the same token, if we're going that far, if you have a sprite that you're just drawing, and its parameters, it's like sprite index, image index, scale, those parameters aren't changing every frame, you could also just like make them sprite assets in the room editor. Like, use an asset layer like this. You can drag them into the room manually. You can drag them into the room manually. You can spawn them on an asset layer using code. And that is probably a better optimization in most cases than doing something like this.
Hey.
I am doing this in Wizardux when it comes to drawing grass, because there are some circumstances in that game which make sprite assets not really a viable option. But you can look at your game and you can decide for yourself if this is something that's worth using, or just something that's mildly interesting and a fun GameMaker fact that doesn't have any bearing on your life. So I think I'm going to end this off here. My name is Michael. I like wizards and dragons and making games. You should all go check out Wizardux and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to the Steam page can be found down below. I like to post videos on all kinds of stuff you can do in GameMaker, so if anything like this appeals to you, feel free to subscribe. I post videos that are more useful than this usually, I promise. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places, and if you felt like pledging, I definitely would appreciate it. Otherwise, I hope you all found this interesting, and I will see you all later. Special thanks to Zenjamin, Zach Robinson, Squarecrow, Spydie Games, Pixelated Pope, Paradox, Nykotic, Manta Ray, GameMaker, GameArt Indie, Edward Holt, DJ Gibbles, Brenton, Bokeh Dev, and Argo the Knot for supporting these videos. If you want to join the ranks of these very cool people, head on down to the Patreon page in the video description to join the fun.